Good morning. Good morning, Mary.
Good morning, Mr. Woodups.
How are you?
I'm good. How about you?
I'm good, thanks. Hey, you want to work through some problems together here?
Sure.
All right, give me just a moment. Let me pull them up.
Okay.
So I assigned 10.2.
Yeah.
So let's look at the homework for that. Would be inverses. Have you already taken a look at it?
Yeah, taking a look at it.
How's it going so far?
Still need to go over some problems.
Well, I'll let you decide where we're going. If there's ones you'd like to look at specifically, let's focus on that.
Okay.
You have one that you'd like to start at?
Should we try one?
Yep. Let's look at one.
Okay.
So, basic idea of the inverse is to switch x and y. And so, if we look at number one, this point down here at the bottom is 0, 2. So if we go to, I'm sorry, it's at 0, negative 2. And so we go to negative 2, 0. And I put a dot there.
Okay.
This point here is at 2, 1. So I go to the point 1, 2. I put a dot there. Up here, this is 3, 5. So I go to 5, 5, 3. And this point at 4, 13 would be at 13, 4, and it'd be somewhere off here. And then I noticed that how it goes, the blue line that's already graphed there goes down and seems to sort of hug negative 3. So I'm going to go down here and hug negative 3 in x and draw this line, and that's sort of what it looks like. Does that make sense?
Yeah.
All right, let's look at the next one. This point here, what point is that, Mary?
Would that be, let's see here. Is x and 4. Would that be like
What's its x coordinate?
trying to think.
Now x tells whether it's going right or left. Does this point here, the red point there in the middle,
It's
Did it go-
going left.
It didn't go left or right because it's right on the y-axis.
Oh, okay.
And so its x coordinate would be
But it'd be like infinity and then try to think of another one, but 0?
it would be 0.
Oh, okay.
The origin, the point right at the where the two x's cross is 0, 0. And that's 0 in x because it's not moved left or right. And it's 0 in y because it's not moved up or down.
Nope.
I'm going to erase it though.
Okay.
So, so this point here is the point 0. What's its y coordinate?
2. Would that be 3?
It would be 3. And so the corresponding point of the inverse of this would be 3, 0.
Okay.
Now, if you look down here, it's got it labeled pi over 4 and pi over 2, but we're just going to consider that this is 1, 2, 3, and so on.
Yeah.
All right. So over here, we've got -4, 2. And so the inverse would be at 2, -4. Down off the graph, but we get the idea here. And here, 4, 4. When you switch them, it's still 4, 4. So that's what that graph would look like.
That's an interesting line.
Now, if this the y scale is longer than the x scale, if they were the same, it would be a little easier to see. But this line, matched by the dotted line here, is the line x equals y equals x.
Mm-hmm.
And when you've graphed an inverse, a function and its inverse, it looks like a reflection in the, it should appear to be a reflection in that line y equals x.
Okay.
It'd probably be easier to see in number 3. You want to do number 3?
Yeah, let's do number 3.
Okay. You tell me what point this is.
That is 1, 3.
Switch them.
3, 1.
Yeah, this is the point 3, 1 because it's 3 in x and 1 in y. Goes over to the right 3, which is x, and up 1, which is y. So this point 3, 1 in the inverse would be 1, 3. How about this point right here?
That would be 1, 3. We'll switch it. That'll be 3 and 1.
This point right here.
That right there.
2
and 2.
2, 2. So when I switch 2, 2, it's still 2, 2.
Yep.
Okay, how about this point right here?
That would be 4.
Wait, your x goes first. So right or left?
That'll be 1 and 5.
Excellent. So that's the 0.15. So its inverse would be 5, 1.
Yep.
So with this problem where we started at 3, 1, we're going to start at 1, 3.
Okay.
I'm going to go through 2, 2. And then we're going to go over to 5, 1.
Mm-hmm.
And we continue over that way.
Okay.
And if you look at that in terms of the line y equals x, you can see how they're reflected over that line.
Yep.
Easier to see in this case because x and y are the same scale. They're the same distance. They're little squares rather than rectangles like you see over in number 2 and in number 1.
Yeah.
All right. Which one of these would you like to see?
How about number 9?
All right. So with number 9, the first thing we want to do is think that f of x is the same as y.
Yeah.
So we could rewrite that as y equals 2 times the parentheses x plus 3 squared minus 4. And this is for the values of x greater than or equal to negative 3.
Mm-hmm.
So then what we do is we switch. So where there's a y, we put an x. So instead of y equals, we're going to say x equals 2 parentheses y plus 3 squared and minus 4. And then we're going to solve for y. We're going to try to get y here alone.
Yeah.
So the first thing we want to do is add 4 to both sides. So we've got x plus 4 equals 2 times y plus 3 squared. And we got rid of this minus 4 by adding 4 to both sides. Adding 4 here made that 0 disappear, and then it left it over here on the left as x plus 4.
And will we divide 2 both sides?
Yes, excellent. So we take this side and this side, divide by 2. That cancels the 2. So then we've got x plus 4 over 2 is equal to y plus 3 squared. We then take the square root of both sides.
Mm-hmm.
When you take the square root, you take the positive or negative. We took the square root to get rid of the square here, so that leaves y plus 3.
Minus 3. And we minus 3 both sides to get the y alone.
Yep. So I'm going to write that minus 3 off to the front of this. So there's minus 3 plus or minus the square root of x plus 4 over 2 is equal to y. And so f of f inverse of x equals I didn't leave myself space to do that here.
You're good.
So I'm just going to rewrite f instead of y. I'm going to write f minus 1. That's the inverse function of x is equal to minus 3 plus or minus the square root of x plus 4 over 2.
Will that be the answer?
I'm trying to think here what
Oh, okay.
if we yeah, that would be the answer.
Okay.
Wait. X greater than or equal to negative 3. If we look at this function here, let's go over to Desmos. Have you seen Desmos, Mary?
Yeah, I've seen decimals. Let me. Decimals. There we go. Perfect.
All right, you still with me?
Yep, still with you.
So at 2 parentheses x plus 3
Plus 3.
and then squared minus 4 So this point right here only includes the values from x greater than or equal to negative 3. So only to the right here.
Okay.
So I don't know if I can draw on this. I can't. Let me just move off to the side here for just a second. If the equation itself only looks sort of like this, because it only includes the values to the right of the vertex,
Mhm.
the reflection would be like this. Okay.
Okay.
That means it doesn't include both a plus or minus. It would only include the plus. It would only include the top part. If it included both plus or minus, it would look like this.
Okay.
That's not what we have, so
No.
so this would be our inverse down here.
Okay.
All right, and that's it. That's how you do it. What other ones would you like to look at?
Let's look at number 12.
Okay. I'm gonna pull up a different place to work on that.
Okay. Do you want me to do the whole homework, or do you want me to do the odds?
That's a good question. Did I specify that it was just the odds?
Yeah, I think you specified the odds, I think.
Let me just look real quick.
Okay.
I didn't specify that it was just the odds, I don't think, Mary, but you can just do the odds.
Okay.
With the exception of 1, 2, and 3, which we've done together, so make sure you get those in there included.
Yeah.
Number 12. We've got f of x equals 3x plus 5 over x minus 1. Okay, so what's our first step?
Do you need to like get the x alone?
We want to substitute out f of x. Instead of f of x, we write
Don't you write the inverse, like x minus 1?
f of x is y, right?
Yep.
Then we switch. X equals x equals 3 blank plus 5 over blank minus 1. And in the blanks, I'm just trying to do this by colors here.
Okay.
Wherever there was an x, we put the y. And wherever there's y, we put x.
Okay.
And then we want to solve for y.
Yes.
So since this equation is being divided by y minus 1, I'm going to multiply both sides by y minus 1.
Yeah.
X times y minus 1 equals 3y plus 5. Okay, do you understand what I did there?
Yeah.
Then I take x times y, be xy, and x times minus 1 would be minus x. So just distribute the x there, equals 3y plus 5. And I want to get y alone, so I'm going to get all of my y's over on the one side and everything that doesn't have a y on the other side. So
Okay.
I'm going to have, xy, subtracting 3y from both sides leaves minus 3y. And then adding x to both sides gives me x plus 5. Does that make sense?
Mm-hmm.
And then since both of these have a y in it, I can factor the y out. So I'm going to write y times x minus, what would the other thing be?
-3.
Minus 3, parentheses, equals x plus 5. Can you see what the last step would be?
Divide x -3 both sides.
Excellent. So I've got y equals x plus 5 over x minus 3. And then finally, instead of leaving this as y, we're going to rewrite it as f minus 1, or the inverse of x, of f inverse of x, equals x plus 5 over x minus 3.
Okay.
It was a little tricky, but once you get the hang of it, you know, it's not too hard.
Yeah.
You can do it.
Yeah.
All right. I think I'll do one more with you.
Yeah. Can you do 17?
17. I can do 17. Can you do 17?
Sure.
I will write what you tell me to write. How's that?
Okay.
So we've got f of x equals -2 cube root of x minus 5 plus 7. Okay, tell me what to do.
Okay. So the f of x needs to be f of y.
We just need to change that to y.
Yeah.
Okay.
So what we need to do is x minus 5 supposed to be y minus 5, or is that the same?
So now we need to switch x and y.
Yeah.
So where there's a y here at the beginning, we now need to write it as x.
Yeah.
X equals -2 cube root of y minus 5 plus 7.
Okay, what we need to do is get y alone. Subtract 7 by both sides, because it's out of the. Yeah, subtract 7 on both sides.
Oh, I'm sorry, subtract 7. X
Yeah.
minus 7 equals -2 cube root y minus 5. And then I've already subtracted 7, so there's no 7 there anymore.
And divide 2 both sides.
Right. I'm going to offer that we divide by -2 both sides.
Yeah.
So that cancels the -2.
Yep. Then we use, how do we get rid of that cube?
So because it's a cube root,
Yeah.
what's the inverse of taking the cube root of something?
That is a tough one.
So let me give you a hint here.
Okay.
The cube root of 8 is 2. Why?
Hmm. Is it
Didn't-
because I'm trying to think. I have no idea. Because this is a new one for me.
So the cube root asks the question, what number times itself 3 times equals this number, which in this case is 8. And so the number that multiplied by itself 3 times is
Yeah.
8, is 2, because 2 times 2 is 4 times 2 is 8.
Oh.
So going this direction,
Mm-hmm.
the cube root of 8 is 2, because 2 times 2 times 2 is 8.
Yeah.
And here, 2 cubed is 8 because of the same idea. 2 times 2 times 2 is 8.
Yeah.
And so these are opposite operations of each other. The opposite of cube root is cube.
Okay.
So we take the cube of both sides. We elevate them both to the third power.
Okay.
So we would take this side, and then we would raise it to the third power. And we take this side, y minus 5 cube root, and we cube it, which undoes that operation, just like division undoes multiplication or subtraction undoes addition.
That cross off the cube root.
The cube root, the cubing something undoes cube root of something. So
Okay.
we're left with y minus 5 on the right, and over here we are left with x minus 7 over 2, negative 2, cubed.
Okay. And we add 5 to both sides to get the y alone.
So then add 5.
And then cross off. Would the
X minus,
positive 5 be out of the parentheses or in the parentheses?
it would be outside the parentheses.
Yeah, that's what I thought.
Plus 5 equals y. And at this point, I'm going to just skip that last step where I rewrite it and just say y is
Yeah.
of negative 1, sorry. F negative 1, or the inverse function of x, is equal to, well, all of this.
Okay.
And that's right.
Alrighty. Thank you, Mr. Woodups.
Hey, you're welcome. So you think you can do the rest of these on your own?
Yeah, I'll do my best.
If you run into troubles, send me
I'll
an
let you
email.
know.
Or this is my Google Voice number. I've already shared this with you?
Yes, you did.
All right. Well, there it is again. And if you need trouble, sorry, if you have trouble and you need some help, feel free to either call me or text me at this number, and we can get back on. We can do another meeting, and I can show you my screen, and we can work through some problems if you need to.
Okay.
I think you don't need my help, but if you do,
I'll let you know.
here it is. And for anyone watching this video, because I'm recording this, same thing applies. If you guys need help, please feel free to call me or text me at that number.
Alrighty. Thank you, Mr. What Ups.
Mary, thank you for coming. Appreciate your being here.
Yep, no problem.
Have a great day.
You too.
Bye.
Bye.